Hello students, welcome you all in this video where I am solving science model question paper 4 for the year 2025-26, and in this video I am going to start with 3 marks question of part B chemistry. So let's start with the question. So in this section, that is Roman number 9, we are going to solve 3 marks question. Here you can see we have to solve 3 questions. Each question will carry 3 marks. So total we are going to get 9 marks from this section. So we will start with question number 22. Write the balanced chemical equation for the following reaction. So here we have 3 reactions and we have to write the balanced chemical equation for this. So remember, in chemistry chemistry section, that is part B section, compulsory this type of questions will come. So practice how to write the balanced chemical equation, practice some of the reaction and try to practice the reaction from your textbook, NCERT textbook, and from that textbook only the reaction will be asked in the exams. So we will start with the first one. Calcium carbonate gives calcium plus carbon dioxide. So for this we have to write the balanced chemical equation. You can see this is the example of decomposition reaction where one substance is broken into 2 or more products. So calcium carbonate, what is the formula for calcium carbonate? It is CaCO3. This is the formula. Calcium means Ca, carbonate means CO3. So remember, we should know the oxidation states of these ions. So calcium it is +2, carbonate it is -2. So we have studied in our 9th standard. We can write the formula for this. So Ca will become, this 2 will come this side, and for CO3 these 2 will go that this side. Now 2 is same, so we can cancel it and we can write our formula CaCO3, and therefore the calcium carbonate formula is CaCO3. This will break to give calcium oxide. Calcium is Ca, oxide is O, and then we are getting CO2, that is carbon dioxide. So remember, calcium carbonate is solid in state, CaO is also solid in state, calcium oxide, but CO2 is in gaseous in state. So you have to write the states of this. And now you count the atoms on left hand side and right hand side. You see here calcium is 1, here also it is 1, carbon is 1, this side also it is 1, oxygen this side it is 3, and this side 2 plus 1 will be 3. So let me write it. Calcium we have 1, here also it is 1, so done. Then carbon we have here 1, here also we have 1, so this is also done. And then we have oxygen, here it is 3, and here this side, here it is 1 and here it is 2, so total 2 and 1 will become 3. So here oxygen also has got balance. So therefore the balanced chemical reaction is, so let me write it here on the side once again so that you should not get confused. CO3 solid gives, so I'll make here 2 arrows so that you should not get confused. Here it is CaO solid plus CO2 gas. So this is our balanced chemical equation for the first one. I hope you understood this. Now the second one, hydrogen plus chlorine gives hydrogen chloride. Very simple. What is hydrogen? It is H2 and it is in gaseous state, as we all know. Chlorine, it is Cl2. It is also in gaseous state. And when these two combines, we are going to get HCl. This is also in gaseous state. So here I wrote 2. Why? Because here hydrogen is also 2, Cl is also 2. You can see here this is also 2, this is also 2. And if I write it 2 here, then H will become 2 and then Cl will also become 2, and therefore this reaction is also balanced. Now the next one, magnesium plus hydrochloric acid gives magnesium chloride plus hydrogen. So what is the symbol for magnesium? It is Mg and it is a metal solid in state, plus hydrochloric acid HCl. So it is in aqueous state. So remember, write down this, and it is giving magnesium chloride MgCl2. Why MgCl2? Magnesium is +2 and Cl chloride is -1. So here Mg, cross the valencies, 1 comes this side and this 2 of Mg will go that side, and therefore the formula becomes MgCl2. No need to write this 1. Nothing is there means it is considered that there is one. So that's why the magnesium chloride formula is MgCl2. This will be in aqueous state, and then we are getting hydrogen gas, that is H2, gaseous state. Now count the elements on the left hand side, right hand side. Mg is 1. Here also it is 1. Done. It is balanced. Now H here it is 1, but this side H is 2. Cl is 1, but this side Cl is 2. And to balance this, we will write it here 2. Therefore, this also becomes 2, this also becomes 2, and everything will get balanced. So, this is the balanced chemical equation, that is for third one. Mg plus magnesium plus hydrochloric acid gives magnesium chloride plus hydrogen. So, I hope you understood this answer for this question number 22. Now, we'll move to the next question. Now we'll start with question number 23, which is consists of sub question A and B. So we'll start with the A. The question says, what is neutralization? So remember, neutral means which has equal number of H plus ion and OH minus ion, means it is not acidic, it's not basic. That is called as neutral. So what is neutralization? So the answer is, neutralization is a chemical reaction in which acid reacts with base to form salt and water. This is called as neutralization, and usually the release of heat, there will be small amount of release of heat. So remember, when acid combines with base, we are going to get salt plus water, and this reaction is called as neutralization reaction. So here acid and base will combine each other, and they will remove the properties of each, they will cancel the properties of each other, and therefore the salt, whatever it is forming, it will become neutral, and this process is called as neutralization. Now the sub question B says, name the acid present in the following substances. Very simple. So they have asked curd. In curd, the acid present is lactic acid, and gastric juice, the acid present is hydrochloric acid. So this is the answer for question number 23, which was very simple. Now we are going to start with the next question. Now question number 24, explain the formation of ionic bond between sodium and chlorine atom. So we have to show the formation of sodium chloride. How the bond is formed between sodium and chlorine. So what is ionic bond? The bond which is formed by the combination of ions, that is cation and anion. The bond which is formed by transfer of electron from cation to anion, it is called as ionic bond. So start with the answer. So step 1, first we will see the electronic configuration of sodium and chlorine. So sodium, that is Na, its atomic number is 11, means it has 11 electrons. So these 11 electrons, when we arrange in our shells, that is K, L, M and N, then it will look like this, 2, 8, 1. So we can add 2 electrons in the K shell, then out of remaining 9, 8 we can add in the L shell, and 1 we can add in the M shell. So you can see here M shell will be the last shell, or I can say valency shell, that is M. Now, 1 electron in the valency shell. So here we have only 1 electron, and to complete the octet, either it has to take 7 electrons or it has to lose this 1 electron. This we have to remember. Losing 1 electron is very easy compared to taking 7 electrons. Now come to chlorine. Chlorine atomic number is 17, so it has 17 electrons. Now write down the electronic configuration. Here only I will write it. I'll change the color of the pen. So here 2 in the K shell, 8 in the L shell, and M shell has 7 electrons. So here also M shell is the last shell or the valency shell. Now see, to complete the octet, either it has to lose this 7 electron or it has to take 1 electron. So you can see here, taking 1 electron is very easy compared to giving 7 electrons. So that's why I have written need 1 electron to complete the octet. So here in case of sodium, giving 1 electron is easy, and in case of chlorine, taking 1 electron is easy, and therefore now sodium will give the electron and that electron chlorine will take. So that is called transfer of electron. Now see the next step, transfer of electron. Sodium lose one electron to achieve stable octet. So see here, sodium has atomic number 11. It gives one electron, it becomes Na plus. You can see here, and here the number of electrons will be 10. One electron is out. I hope you understood this. Sodium, which was having 11 electrons, now when it became Na plus, electrons are 10 and protons are still 11. I hope you are understanding. Atomic number 11 means what? Protons are 11, electrons are 11. But when the sodium loses one electron, it has only 10 electrons now. Na plus has only 10 electrons, but it has 11 protons. Protons are more, and therefore Na we will write a positive charge. So that's why we will get Na plus. Same way, chlorine gains that electron. So chlorine will take the electron. So chlorine, if you see, it has 17 electron as well as 17 proton. But when this chlorine will take one electron, now what happens? See, this chlorine, I'll write it here, chlorine will become minus. Why? Now it has 18 electrons and 17 protons. So electron negative charge is higher. Therefore, Cl will get a negative charge. So like this, we got one positive ion Na plus cation, one negative ion Cl minus. And we know opposite charges always attract each other. And therefore, sodium and chloride ion will attract each other to form an ionic bond. So we will see it. Sodium becomes positively charged ion Na plus due to more protons. I'll write it here. More protons. How many protons it has? 11. Chlorine becomes negatively charged due to more electrons. How many electrons it has? 18, not 18. Yes, 18 electrons. The electrostatic force of attraction between Na plus and Cl minus forms an ionic bond, and which can be shown by Na plus Cl minus gives NaCl, that is sodium chloride. The same thing can be shown by the formation of the transfer of electron. Let me show it here on the side. So here I will write sodium has one electron here, that is outermost shell, plus Cl has 7 electrons. So see here 7 electrons, but still there is one place which is empty. Now what happens? Na will lose the electrons and Cl will gain the electron. So see what happens? Na becomes Na plus and positive charge here, and Cl will become Cl minus, and therefore both will combine to give NaCl. And this is the reaction of formation of ionic bond between sodium and chlorine atom. So I hope you understood this answer. Now I'll move with the next question. Now we will see the internal choice, that is the OR option for this. So in this OR we have again A and B sub question. We'll start with A. Write the chemical reactions to prove that aluminium oxide is an amphoteric oxide. So aluminium oxide, that is Al2O3, is an amphoteric oxide. What is amphoteric? The oxide which act as acidic as well as basic. So as we all know that metal will always form basic oxides. Basic oxides and non-metals. Non-metals will always form acidic oxides. Acidic oxide. But there are some exceptions. There are some metals which will show these both the properties, acidic as well as basic, and those oxides are called as amphoteric oxides. So in this we can see aluminium, even we can see zinc. So here the question is for aluminium. We have to prove that this is an amphoteric oxide by chemical reactions. So this is, everything is there in the NCERT book. So see here, to prove that aluminium oxide is an amphoteric oxide, we show that it reacts with acid as well as base. Whenever it will react with acid, it will act as a base. Whenever aluminium oxide react with base, it will act as acid. Very simple. So first we will see the reaction with the acid. Now see here, when aluminium oxide reacts with hydrochloric acid, so here it is aluminium oxide and this is here HCl, that is hydrochloric acid. Once it reacts, it gives aluminium chloride. What is this aluminium chloride? It is a salt, and we are getting here water. So what is this reaction? You can see here, we are getting salt and water. See, we are getting salt and water. When we will get salt and water? If acid and base react with each other. Now if you focus the reaction, HCl is already a acid, hydrochloric acid. Here we have got salt and water. Then what is this? Aluminum oxide. It is acting as base. That is basic nature. Now see the reaction with the base. Here we are going to take aluminum oxide and react with base, that is sodium hydroxide. We know that sodium hydroxide is a base. So see here, we are getting this salt which is called as sodium aluminate. It is a salt, and we are getting here water. So according to this reaction, if we are getting salt and water, and if this is base, then what is aluminum oxide? It is acting as acid, so it is showing acidic nature. So in above reaction it has shown basic nature. Now it is showing acidic nature. Means this oxide is showing this both acidic as well as basic nature. So it is called as amphoteric oxide. Very simple. Now we'll see the question number B. How calcination differ from roasting? So here I have written the differences. See, here I have written 4 differences with one example, and same I have compared with roasting with one example. So try to write the differences in the columns like this. Don't write like this. So here you write for calcination and here you write for roasting, and same you can write in the points like this. So it will be easy for examiner to correct. So in the next video, whenever I'll write the differences, I'll make the columns like this. So you people remember, whenever differences will be asked, not in the calcination and roasting, it may be in the any topic, differences should be written in the column. So now we'll start calcination. So the first point, heating of ore in absence or limited supply of oxygen. So in calcination, ore will be heated in the absence or limited supply of oxygen. So in the same point we have to write for roasting. It is a heating of ore in presence of oxygen or in excess of oxygen. So here it is absence, here presence, here limited, and here excess. So this is the first difference. Second, used mainly for carbonate and hydrated ores, and here it is used mainly for sulfide ores. Remember, here oxygen is less. Why? Because already the ore has oxygen. Here oxygen is more because ore don't have any oxygen that we are going to supply from outside. So remember, second difference, it is applied for carbonate and hydrated ores, and this process is applied for sulfide ores. Third one, removes moisture and volatile impurities, because once we heat this ore, it will convert into a volatile impurity. Here it converts sulfide ores into its oxides. We are adding oxygen, and therefore all the ores will convert into oxides. So see here, it will convert into oxide. And the fourth difference, converts carbonate ores into oxide ores. Sulfur is removed as SO2. So here if you use carbonate, it will become oxide and CO2 will be removed. You can see here CO2 is a gas, goes off. So I have taken zinc carbonate, heated. Zinc carbonate will become zinc oxide and CO2 will be removed out. In case of this, I have used sulfide ore. Once we heated with the oxygen, that sulfur will become sulfur dioxide gas and it will be removed out, and our zinc becomes zinc oxide. So these are the 4 differences. If you see example, then it will be of 5 differences. In this question, 2 differences are enough because it has A and B sub question, but I have given just for extra information. If the same question is asked for 4 marks or 5 marks, you should remember. So this is for your information. I hope you will understand this answer for this question A and B. Now I'll move to the next question. So here student, I have finished all the 3 marks question from this part B chemistry of this model question number 4. I hope these all the answers will help you to prepare for your final exam. If these all the videos are helping you people, then please consider subscribing my channel and share my videos with your friends. Thank you so much.